Good day, students. I am Miss Angela R. Moresco, a grade 10 mathematics teacher, and I am here to discuss about the rational root theorem. After going through this lesson, the learners are expected to determine all the possible roots of the equation and develop patience in solving the equation using rational root theorem.
Before we proceed to the discussion proper, learners must remember the following. First, leading coefficient. Leading coefficient is the numerical coefficient of the term with the highest degree in a given polynomial. Second, constant term. Constant term is an expression or equation that contains no variable. Later, I'm gonna give you some example of these too. Let us now discuss the rational root theorem. Let a sub n minus 1 x raised to n minus 1 plus a sub n minus 2 x raised to n minus 2 plus a sub 1 x plus a sub 0 equals 0 be a polynomial equation of degree n. If p over q in lowest terms is a rational root of the equation, then p is a factor of a sub 0 and q is a factor of a sub n. Please take note that p is a factor of the constant term and q is a factor of the leading coefficient. These are the two that I have mentioned earlier. Let us have our first example. Find all the possible roots of x cubed minus 6x squared plus 11x minus 6 equals 0. Our leading coefficient here is positive 1 because that is the numerical coefficient beside the variable with the highest exponent. And our constant term here is negative 6 simply because that is the only term that do not contain any variable. To easily find all the possible roots of our given equation, we need to set values for p, which will be coming from the factors of our constant term, which is negative 6. And its factors are positive negative 1, positive negative 2, positive negative 3, and positive negative 6. Same thing with q. In q, we need to use the factors of the leading coefficient, which is positive 1. And its factors are positive, negative 1. We have to use the formula p over q to determine all the possible roots of our given equation. All we have to do is to use the factors of our constant term as our numerator and the factors of our leading coefficient as our denominator. So we will be having positive negative 1 over positive negative 1, positive negative 2 over positive negative 1, positive negative 3 over positive negative 1, and lastly, positive negative 6 over positive negative 1. Answers must be in lowest term, so definitely our answer here will be positive negative 1, positive negative 2, positive negative 3, and positive negative 6. These are all the possible roots of the given equation x cubed minus 6x squared plus 11x minus 6 equals 0. On our second example, we need to find all the possible roots of 4 minus 5x squared plus x to the fourth power equals 0. What have you noticed to our given equation? Yes, you're right. It is not yet written in standard form. So we have to rearrange our given equation and write it in descending order. So we will have x to the fourth power minus 5x squared plus 4 equals 0. our leading coefficient here is still positive 1 because that is the numerical coefficient beside the variable with the highest exponent. And our constant term here is positive 4. Again, because it is the only term that do not contain any variable. So to determine all the possible roots of the given equation, we need to get the factors of p, or the constant term, positive 4, which are positive negative 1, positive negative 2, and positive negative 4. Same thing with q, which are the factors of the leading coefficient positive 1, and these are positive negative 1. We will still use p over q to determine all the possible roots of the given equation. So, we will be having positive negative 1 over positive negative 1, then positive negative 2 over positive negative 1, and positive negative 4 over positive negative 1. To make it in lowest term, we will be having p over q equals positive negative 1, positive negative 2, then positive negative 4. All of these are the possible roots of the given equation x to the fourth power minus 5x squared plus 4 equals 0. Next in line is example number 3. Find all the possible roots of 2x cubed minus x squared minus 4x plus 3 equals 0. If you would notice, our given equation is already in standard form and it is written in descending order. So all we have to do is to get the leading coefficient and constant term. The value of our leading coefficient here is positive 2 because that is the numerical coefficient beside the variable with highest exponent. And our constant term here is positive 3 because that is the only term that do not contain any variable. Same thing with what we have done in examples 1 and 2. Get the factors of p, or our constant term, and factors of q, our leading coefficient. So the factors of our constant term positive 3 are positive negative 1 and positive negative 3. Then the factors of our leading coefficient positive 2 are positive negative 1 and positive negative 2. Always remember that each factors of p will be divided into each factors of q. So positive negative 1 will be divided into positive negative 1, then positive negative 3 will be divided in positive negative 1. Next is positive negative 1 will be divided in positive negative 2, and positive negative 3 will be divided in positive negative 2. Reducing this in lowest terms, it will become positive negative 1, positive negative 3, and then positive negative 1 over positive negative 2. Same thing with positive negative 3 over positive negative 2. These are now considered as the possible roots of the given equation 2x cubed minus x squared minus 4x plus 3 equals 0. On our fourth example, find all the possible roots of 3x cubed minus 19x squared plus 33x minus 9 equals 0. Is it already in standard form? Yes, you are right. Now, let us determine the value of our leading coefficient. It is positive 3. And our constant term here is negative 9. Again, get the factors of our constant term, and that will serve as the value of our p, and get the factors of our leading coefficient, and that will serve as the value of our q. The factors of our constant term negative 9 are positive negative 1, positive negative 3, and positive negative 9. And the factors of our leading coefficient positive 3 are positive negative 1 and positive negative 3. we'll be doing the same pattern wherein each factors of our constant term will be divided into each factors of our leading coefficient. So we will have positive negative 1 over positive negative 1, positive negative 3 over positive negative 1, and positive negative 9 over positive negative 1. The next set is positive negative 1 over positive negative 3, positive negative 3 over positive negative 3, and positive negative 9 over positive negative 3. As we reduce this in lowest terms, repeated value will only be written once. So positive negative 1 over positive negative 1 will become positive negative 1. Positive negative 3 over positive negative 1 will become positive negative 3. Then positive negative 9 over positive negative 1 will become positive negative 9. Positive negative 1 over positive negative 3 will be the same since it is already in its simplest form, while positive negative 3 over positive negative 3, as we divide this, it will become positive negative 1, which is already written in its simplest form. Same thing with positive negative 9 over positive negative 3. As we simplify it, it will become positive negative 3, which is already in the set of the possible roots. So, the possible roots of the given equation 3x cubed minus 19x squared plus 33x minus 9 equals 0 are p over q equals positive negative 1, positive negative 3, positive negative 9, and positive negative 1 over positive negative 3. You might be asking, why do we need to study the rational root theorem? We are discussing the rational root theorem because it will help us to find all the real roots, or the what we so-called solution set, or the zeros of an equation easily, because we can use all the possible roots to determine the zeros or the real roots of an equation. Let me show you an example on how are we going to apply the rational root theorem in computing the real roots that will satisfy our given equation. Using our previous example, which is illustrative example number 1, the equation is x cubed minus 6x squared plus 11x minus 6 equals 0. And the computed value of our p over q, or the possible roots, are positive negative 1, positive negative 2, positive negative 3, and positive negative 6. All we have to do is to substitute it one by one. I will be starting with positive 1. So, I am going to replace every variable in our given equation with positive 1. So, I will be having p of 1 equals 1 cubed minus 6 times 1 squared plus 11 times 1 minus 6. As we evaluate the given equation, p of positive 1 will now be equal to 0, meaning to say it satisfies our given equation. So definitely, positive 1 can be considered as one of the real roots of our equation. Next, I am going to use negative 1. So I will be replacing again all of the variable on our given equation with negative 1. That will become p of negative 1 equals quantity of negative 1 cubed minus 6 times negative 1 squared plus 11 times negative 1 minus 6. The value of our p of negative 1 is equivalent to negative 12, meaning to say negative 1 is not considered as the real roots of our given equation. Next thing to try is positive 2. We will have p of positive 2 equals quantity of positive 2 cubed minus 6 times 2 squared plus 11 times 2 minus 6, and that is equal to 0. If you would notice, as we evaluate p of positive 2, we got 0. So we can consider also that positive 2 is one of the real roots of our given equation. Let us now try p of negative 2. P of negative 2 is equal to quantity of negative 2 cubed minus 6 times negative 2 squared plus 11 times negative 2 minus 6. As we evaluate this, it will be equal to negative 12. So definitely, negative 2 cannot be considered as the root or zero or solution of our given equation. Let us now proceed in positive 3. P of positive 3 is equivalent to quantity of 3 cubed minus 6 times 3 squared plus 11 times 3 minus 6. As we evaluate this, it will become 0. Definitely, positive 3 is one of the roots or one of the real roots of our given equation. If you will take a look at our given equation, the highest exponent is 3. So definitely, it has 3 real roots. Since we have computed already with the 3 zeros of our given equation, we can finally say that the real roots are positive 1, positive 2, and positive 3. Let us now have another example of finding all the real roots of an equation using the rational root theorem. The given is x to the fourth power minus 5x squared plus 4 equals 0. And the computed possible roots are positive negative 1, positive negative 2, and positive negative 4. The degree of the equation is 4, meaning to say that this equation has 4 real roots. Let us start by using positive 1. Again, we need to replace every variable on our given equation with positive 1. So we will have p of 1 equals quantity of 1 to the fourth power minus 5 times 1 squared plus 4. As we simplify p of 1, it will now be equal to 0, meaning to say that we can use positive 1 as one of the real roots of our equation. Next to try is negative 1. We will be having p of negative 1 equals quantity of negative 1 to the fourth power minus 5 times negative 1 squared plus 4. As we compute this, it will also be resulted into 0, meaning to say that negative 1 is also one of the real roots of our given equation. Let us see as we substitute positive 2. P of positive 2 equals quantity of 2 to the fourth power minus 5 times 2 squared plus 4. Let us now compute this. Oh, it is also equivalent to 0, meaning to say that positive 2 is considered also as one of the real roots of our equation. 3 down and 1 to go. Let us proceed with negative 2. P of negative 2 equals quantity of negative 2 to the fourth power minus 5 times negative 2 squared plus 4. As we compute this, it is also equivalent to 0. Since we have computed already 4 zeros of our given equation, we can finally say that the real roots of our equation are positive 1, negative 1, 2, and negative 2. Based on what you have learned during our discussion, let's see if you can make these practice exercises by simply answering true if the statement is correct and false if it is wrong. You are given a 10-second timer to answer each statement. Good luck! In rational root theorem, use P over Q to determine all the possible roots of the equation. Is it true or false? Your timer starts now. And the correct answer is true. In rational root theorem, P refers to the factors of the leading coefficient. Is it true or false? Your timer starts now. And the correct answer is false, since P refers to the factors of the constant term. In the equation x cubed minus 2x squared plus 4x minus 8 equals 0, the leading coefficient is negative 8. Is it true or false? Your timer starts now. And the correct answer is false, since the leading coefficient of the given equation must be positive 1. The equation 2x cubed minus 6x squared plus x minus 1 equals 0 has no rational root. Is it true or false? Your timer starts now. And the correct answer is false, since 2x cubed minus 6x squared plus x minus 1 equals 0 has rational root, and these are positive negative 1 and positive negative 1/2. The possible roots of the equation x cubed minus 6x squared plus 10x plus 3 equals 0 are positive negative 1 and positive negative 3. Is it true or false? Your timer starts now. And the correct answer is true. Since you have done a good job on your practice exercises, I think that you are now prepared and ready to do this task independently. The direction is determine all the possible roots of the given equation using the rational root theorem. Good luck! Determine all the possible roots of the following equation using the rational root theorem. The first equation is x to the fourth power minus x cubed minus 7x squared plus 13x minus 6 equals 0. Second, 3x to the fifth power minus x to the fourth power plus 6x cubed plus 10x plus 3 equals 0. Next, 2x to the fourth power minus 17x cubed plus 13x squared plus 53x plus 21 equals 0. You may pause the video while answering this task. You may check your answer if it is correct by simply watching the next slide to see if you have made it right. To wrap this up, do not forget the following. Rational root theorem. Let a sub n minus 1 x raised to n minus 1 plus a sub n minus 2 x raised to n minus 2 plus a sub 1 x plus a sub 0 equals 0 be a polynomial equation of degree n. If p over q in lowest terms is a rational root of the equation, then p is a factor of a sub 0 and q is a factor of a sub n. Here are some important things to remember as we discuss the rational root theorem. Leading coefficient. It is the numerical coefficient of the term with the highest degree in a given polynomial. Constant term. Constant term is an expression or equation that contains no variable. Please take note that p is a factor of the constant term and q is a factor of the leading coefficient. To end this up, I want you to hear this quotation. Not everything that can be counted counts, and not everything that counts can be counted, by Mr. Albert Einstein. Again, I am Miss Angela R. Moresco, a grade 10 mathematics teacher. Thank you.
Don't forget to like, subscribe, and share!